Welcome to the part B of lecture 12. In this video, we are going to do some hands-on. So in this hands-on, we are going to load the dataset library, which has the Iris dataset. So if you go to the load the you write Irish. So Edgar Anderson's Iris datasets. It is also known as Fisher's Iris dataset. So it has, Irish is a English flower which has 3 subspecies. One is called setosa, one is called versicolor, and one is called virginica. In this dataset, what happens is, if you just say, let's say Irish, head Irish. So it has 4 predictors: sepal length, sepal width, petal length, and petal width. These 4, based on these 4 phenotype, can you say which species the flower belongs to? Okay, so what I have done here, for different colors, setosa, versicolor, and virginica, I have given different color. For different species, I have now add different color. So now if you go to head Irish, so you will see that along with that, let me just, so now this is a new column. That last column is a new column. For setosa, I had blue, versicolor I have given red, and virginica I given green. Now if you run this piece of code, I just plotting from Iris dataset. I'm just taking the sepal length and sepal width. I'm just extracting it and giving it as a x value and y values. And if you run this plot, then you got this plot. You can give a grade also. So you can see these are like blue or setosa. We have given blue as setosa, red points are all versicolor, and the green points are virginica. Now what I have done in that data set, I have created a one-hot encoding for setosa. If it is setosa, then it will have a 0 or it is 1. So for all it is 0, but whenever it will find setosa, it will get a 1. Otherwise it will be 0. So now the data set, let me just show you how the data set look like now. Irish. Okay, so let me just, so first few values are setosa, and then when it is versicolor, it is coded as 0. When it is virginica, this is coded as 0. Okay, and the column name is setosa. So that's how I created a one-hot encoding or binary class variable. Sometimes it's called indicator variable. So let me run the model. GLM setosa as a function of sepal width, data equal to Iris. You give family equal to binomial, link equal to logit, and if you run summary fit, then this is the fit that you will get. If you run the beta, you can, from the fit, you can extract the coefficients. Now in the beta I have the coefficient. Now what I'm going to do, I'm going to calculate, create a X matrix with 100 values, with which X2 takes values with minimum value of sepal width to maximum value of sepal width. So if you just run it, so minimum is, I think 2.2 is the minimum, and max is the 4.4, and in between it just fill up with some values in an equal width, and then I calculate the eta. These are the eta values or z values, latent variable values, and then I calculate the probability, and then I plot the x2 versus sepal width versus sepal width versus the probability of setosa. So if the sepal width increases, clearly probability that the flower is setosa increases. So you can put a grid also in this. So that's how we you can draw probability of p. You can plot p against some predictor values. So I'll stop here, but this Iris data set shows you that your target variable could be not necessarily has to be binary class. It could be multi-class variable, and then in that case you have a multi-class classification, because you have 3 class here. Remember that you have to do 3 class, not binary class. You have a setosa, versicolor and virginica. 3 subspecies are there. When you have more than 2 class, basically it is a k class problem or multi-class problem. The most popular and the old and tested method is linear discriminant analysis. So in the next video we are going to start linear discriminant analysis, or Fisher's linear discriminant analysis. So for now, thank you very much for your attention. See you in the next video.